All right, so this is going to be 50 practice problems and very limited commentary. If you've done the first 25 lesson sets, then I don't think much is needed in terms of commentary. So equation of a line through 2, 5, x minus 2 plus 5. From 5 to 14 is a change of y and 2 to 12, change in x, and so there's our function. 47 divided by 2 is 23, so therefore I squared to an odd number is -1 to an odd -1 times -1 times -1, so on and so forth. So that's a negative, right? So this is a negative number with an extra I to get to 46 and 1 make 47, so -7i. Let's get that out of the way. Let's get that out of the way. Let's get that out of the way. All right, maybe I won't erase as we go along. It takes too long. That's probably mx plus b form. So we've got y equals -11/3 x. And we've got 44 minus 15 is what? 44 minus 15, 29. And it looks like it's positive 44 minus 15, 29. So positive 29/3. Could make a careless error here easily. Minus 3i to 7i is minus 21i squared. So that becomes positive 21. 21 plus 10 is 31. And then we've got minus 6i plus 35. Sounds like I did this problem yesterday. Probably forgot to erase it. So that's positive 29i. Should be able to do this in your head. So that's minus 15 divided by minus 2, 15 halves. And I think I covered all of those. All right, so let's move on. Just a practice session here. Should be able to do this problem in your head as well. So adding 9, dividing by 3 gets us 3, plus minus the square root. Subtraction of 2 becomes addition of 2. So that's the solution for x. All right, this one here probably have to do some writing. Might lose track of things, so we're going to multiply by 15. So we got minus 35x. We got minus 75. And that's equal to 3 times 3x, 9x. Minus 30. Hopefully the numbers speak for themselves. Bring that this way, 44x. Bring that this way, minus 45. And so we got minus 45/44 is our x value. All right, so we'll always write down, when you're writing products, write down all of whatever has to be true. So what has to be true here? Well, an x and an x, to get x squared, has to be true. I can get that. And 5 can only come from 5. Let's put the bigger number at the end here. And 1. So we got to have a 5 and a 1. Now the question is, what is going to get us 6? Well, that's the possibility of 1, 2, 3, and 6. And if I multiply by 5, well, 30 doesn't get me close to 1. 15 doesn't get me close to 1. 5 times 2, I don't think that gets it. So it sure looks like this might be 1, and this might be, well, I lost track of my train of thought here. So this is probably 3, 2, but now I got myself totally stuck because I'm talking to you. So let me get away from this here for a second, step back. 5 times 1, 5, 6, 1 and 6. Okay, so that's got to be a 6. That's got to be a 1. And I want a positive, so that's got to be the plus. That's got to be the minus. Okay, so much for that. Put a 3 in, minus 12 plus 5, minus 12 plus 5, minus 7. When does this equal? -5/7. Okay, well, we can erase that. What's another name for f of x? Another name for f of x. Oh, God, don't do that. -5/7. Another name for f of x is minus 4x plus 5. So substitute minus 4x plus 5. Do the multiplication right now. Minus 28x plus 35 equals -5. And then we can see our answer is 40/28, which I'll take, but reducing that, factor of 4 is common. So we got 10/7. Little better answer. So f of x And that refers to the previous problem. So f of x is minus 4x plus 5, which means that this function is asking you to multiply your input by -4 and add 5. Now, f of x is the same thing as f of, I'm not writing this well, it's the same thing as f of x. And so what am I plugging in? I'm plugging f of x in, which is minus 4x plus 5. And then I'm doing the math. So your answer is positive 16x minus 20 plus 5 minus 15. That's what that answer is. This one here would be nice to get a column to cancel. It looks like the easier multiplication is by -5. So we'll make that minus 5. We'll make that minus 20. And we'll make this positive 50. And hope that I'm not making a careless error here. So minus 23y, when I add these up, is 46. So it looks like my y value is -2. Well, now we'll go back to the original, which was x plus 4y, I believe, equals, I divided by, so -5, I think -10. God, I'm not sure. I'm not sure about that. So I'm going to plug in -2 here, which is positive 6. And so that's going to move over to the other side and become -10. And therefore, x is -2 as well. Boy, was that one awkward. Doesn't matter. I don't have time to do this video today. So you're getting what you get for practice. All right. So binomial squaring at this stage should be old hat. Minus 28x plus 49. Binomial square. Write this as a product. We've got x times x. We got a minus and a minus. It's the only way you can get a positive product is 7 times 1. So that takes care of that. Make this in columns and you'll keep track of things a little better. So minus 6x to the 4th, minus 21x cubed. And this is minus 8x cubed. And this one is minus 10x squared. Add it up. You got minus 6x to the 4th. You got minus 29x cubed minus 10x squared. Hope I'm not making any careless errors. Let's move on. All right, problem like this, you want to have addition of 7 go in the end slot. X squared times minus 5 is minus 5x squared. Minus 2x doubled is minus 4 times minus 5 is positive 20x. Minus 2 squared is 4. Minus 20 plus 7 minus 13. Maximum value. So I know I have a cup shape down. And I know that I'm on the decreasing side, 0's over here, so it's a -12 divided by 4. So -3 is the x that's important. And if I plug it in, I get 36. If I cut that in half, I get 18 plus 3. 21 is the maximum value of that quadratic. Get rid of that. Let's get rid of that. Let's get rid of that. All right. Yep, you can see everything. Vertex. All right, we got a cup shape up. Minus 8 divided by double the 4 is -1 is the x value. -1 gets me -8, cut in half. -4 plus 5 gets me 1. So there's your vertex, -1, 1. What's the graphing form now that we have -1, 1? We've got x plus 1 squared. That's what you do with that number. And you've got the 1 there and multiplier of 4. So there's the graphing form, which means we have our roots. If you set this to 0, you got a -1, you got to divide it by 4, you got a plus minus the square root, that becomes imaginary. Square root of 4th is a half, so therefore we have 1/2 I, and positive 1 becomes -1. All right, those are your roots. This is the same question asked a month ago on a test, except it was asked in this manner, 16x to the 4th minus 1. So you should have had as an answer 1 plus 4x squared, and you should have noticed another difference of squares, 1 plus 2x times 1 minus 2x. I believe that will get you this. This one you should be able to do in your head, plus minus the square root of 8/5. This one you should be able to do in your head, knowing that one of your answers is 0, so you don't have to put it in factored form. You take one of your x's out, and you got 7/9 as your other answer. All right, bingo, bango, bongo. We'll write this out. We still have trouble with this problem. Not quite sure why, but Let's try it again. Bingo. Bango, bongo. All right, and I'm going to leave bongo as x plus 2 times x minus 4, just in case something up here becomes a fraction that I can reduce, which means you got to show the factors anyway. So x minus 4 times 5 is 5x minus 20. X plus 2 times 3 is 3x plus 6. And so now my 5x minus 3x is 2x, minus 20 minus 6 is minus 26. So that becomes 2x minus 26. The factors of this are 2 times x minus 13. I don't see any cancellation, so you can leave it like this as far as I'm concerned. Continuing on. Do I know what I asked here? Of course not. What did I ask? No idea what I asked. What could we do with it? Slope-intercept form, maybe? Then that's a redundant question. No idea. Oh, 3 coordinates. I always ask 3 coordinates. So what are 3 coordinates for this function? Well, I'll start with -5. I'll change by 5, 0, 5, 10. Could do that more than 3 times. +2 is my first y. I'm going to go down by 7, -5, -12, -19. Check one of these numbers just to make sure there's no carelessness. Put a 10 in. We can see a multiple of 5. So 3 times -7, -21, +2, -19. Move on. Tangent. The whole reason I'm asking this is to get used to drawing triangles in different quadrants. We're in quadrant 3, which means this x value is negative. 49 minus 25 square root of 24 minus root 24 is okay as far as I'm concerned for this problem. The tangent is a negative divided by a negative, so this answer was 5 over root 24, which you don't have to conjugate for me right now. Distance. Okay, so we got a place to another place. So I've changed by 5. I've changed by 6. Looks like that distance is 25 and 36, 51. So this is the square root of 51 because a square root is the side of a square. And we're doing Pythagoras like so. Area, area, area. Perpendicular through -411. Let's get this down a little lower. Through -411, I can immediately write x plus 4 plus 11. And the perpendicular is 5 over 2. Go through the first 25 lesson sets. You'll get explanations as to why. Classic Algebra 1 problem. Y varies directly as x and inversely as z. I've got 3 values, 4 unknowns, but I got knowledge about 3 of them. I can solve for the constant of proportionality. Constant, spelled with a K. Keep telling my grandson, he's misusing the letter C. All right, couldn't even see that, but you could hear it. All right, so I'm going to replace all these variables with the numbers I've assigned. So x is 3, so that gives me 3k. Y is 12, that's on this side. And z is 2. All right, so 24 divided by 3, we now know k is 8. So y varies in this fashion. I can now replace z with 4. So 4 goes into 8, that's 2x, and 2x equals 24. I now know my x is 12. Okay, quite possible carelessness happening here, but got to get a practice session in, and I don't have much more time. Name that tune. All right, so if I put a 7 in and square it, I get 49. I don't want 49. I want 23. So there's your function. 0 is the smallest thing that you can get out of squaring, so there's your minimum. FYI, yep, solve for m. Try to help you learn your quadratic formula here. Minus y plus or minus the square root of y squared minus 4 times f times I. Make sure the fraction bar goes under all of that, 2f. If the fraction bar isn't all the way across, then you're not dividing this by 2f, and it will be wrong. Sorry for the pace here today, but best I can do. All right, if you've seen this problem 25 times in the earlier lesson sets, you know we're going to take out what's common between 8 and 12, which is 4. And we're going to start building it right off of that right now. 2 and a 3. 2 minus 3. I need y to the 6th. So I got a common factor of y, so I don't need it here, but I need it here to get back to 6. So y times y to the 5, y to the 6. Z's, I'll take 10 out of this one, which means I need another 13 over here. All right, and at least intellectually, that's written, not written organizationally well, but we're talking thought process here. What do I immediately see here? I see an imaginary square root. So I put that there because I'm highlighting that. 18 is 9 times 2, so that's a 3 and a 2. X to the fourth, I can divide that exponent by 2. I can divide that one by 2, no remainder. I barely have enough room for z. To the 11, 11 squared is 22. Well, power to power 22, so I need another one there. And that one's done. All right, so I need x. X times x is x squared minus 5x. I need 6, so I need minus 1 more. There it is, right there. And now I have minus 1 times minus 5 is positive 5, and I got to get to 11. So 6 over x minus 5. If you want to check to make sure it's positive 6, you can always take the number that makes it 0 here. And this course is based on zeros and ones. Put a 5 in, you get 25 minus 30 plus 11. 36 minus 30, positive 6. We know we're not wrong. All right, so that's there. Factor this, factor the denominator first. So that's probably here without even looking. And it looks like x minus 6 gets the job done. No. I made a mistake again with this problem, didn't I? Oh, that's a 5. All right, so what did I do? I did something stupid right there. Corrected it though. So that's cancel, and your answer is x minus 5 over x. Moving along. Of course, it's based on zeros and ones. We're going to find 2 coordinates here. I'm going to make x 0. Then I got to get 2 out of this. So I got to divide that by 2, which is 1, 4, 9. That's one of my coordinates. Isn't that nice? Of course, I can also get another one by doing what? By making this 315. That gets me 1. Making this 298. And that gets me another one. Okay, just playing around here. All right, so what am I going to do to do this one in my head? That becomes 3, multiplied by 4, that's 12, divide by negative 3, negative 4 is your answer. Minus x squared plus 12 equals x. That's how you find points of intersection. You set the calculations equal to each other. I'm going to bring x squared to the other side. So that gives me x squared plus x. I'm not going to change that sign. It's already there. Minus 12. And now I can see I've got a nice factoring situation here. 3 and 4. I'll put the 4 there and the 3 there this time. Positive, negative. So my answers are negative 4 and positive 3. Let's throw a 3 in just to see it work. 9 plus 3 minus 12. I wonder what that is. Oh, yes, that's 0. Choo! Name that tune. I got a V-shaped down, so I know I got a negative absolute value passing through 3, 7. So x plus 3, negative 3, 7. Okay, and how much of my x has changed? It changed by 6. How much of my y has changed? By 3. So you can change that to negative 2 on your own dime. The 4th root of 6, well, I'm going to flip. No, I'm going to do the 4th root of 16, which is 2. 2 to the negative 3 is 1 over 8. Square root of 7, so we got 7 root 3, right? 21 is equal to square root of 7 times the square root of 3. So there's your picture. 7 root 3. Zeros at 0, comma 3, comma negative 2/5. Moving along. So I'm going to put the 7 there and the 5 here. So that becomes 7 over 5. Which becomes 2, m to the 2. To the negative 3 is m to the negative 6. And we've just started talking about this. These are inverse operations. My answer is negative 6. Okay, remember we've been talking about e to the ln of 2. Is the exponent you put on top of e to get 2. What's the exponent you put on top of e to get 2? ln of 2. We've been looking at e and ln. For the most part, we have not been looking at this as an inverse operation, but it is. All right, so, okay, moving right along. Feel like Monty Python. And now for something completely different. Domain and range. Well, my x's have to be greater than or equal to 3, and my y's have to be greater than or equal to 4. This is what the graph looks like. That's a height of 4. Everything else is above that. This is an x value of 3. Everything's to the right. But it could also equal those values. Sketching 4x squared. minus 8x plus 1. Well, we know it's that. We know it's that. I know I'm on the decreasing side, so there's 0, 1. Therefore, this has to be positive. It's got to be positive 1, 8 divided by 8. And if I put a positive 1, negative 8 cut in half, negative 4 plus 1, negative 3. Hopefully that's correct. Usually put a number there. I must have erased it. Let's put a 7 there just to have some anchoring. So I got a V-shape down, passing through 4, 7. My y-intercept's on the left. I'll put a 0 in. That makes this negative 8 plus 7, negative 8 plus 7, negative 1. All right, it takes care of those. This is point slope form, so negative 5, 3. Negative 5, 3 is the point. The slope is over 4 and up 3. Takes me to a new location. I might as well label it. Not that you have to. If you do this, I'll give you full credit because that's what it's called. Point slope. All right, change by 4. So this is negative 1. If I add 4 to that, and if I add 3 to that, that should work. Let's just plug it in to see. The 4's cancel. And 6 minus 3 is 3. Let's move on. All right, you're supposed to see these numbers. 0 gets me 4, and 0 gets me 6. 0, 4 here, 6, 0 there. You're done, and that's over. And that's the last 50 problems we're going to see in a video. We're moving on. So next video, we'll look at another 70 problems, and that's probably 70 or 80. I don't know, but that's the second half of the course, and we start practicing that on a daily basis. I'm guessing 10 lesson sets will get the job done. And then we turn our attention to more trigonometry. And then we turn our attention to calculus. All right, 100 videos, 100 days. All right, that's a guess. All right, everybody have a good one.